Welcome back to our discussion about rational expression. In this video, we're going to talk about how do you simplify rational expressions. And really, you kind of know how to do this already. Let's just go back for a minute and think about fractions, okay? If I said to you, would you consider this fraction simplified? 6 divided by 8. What would you say? Probably very easily you would say, nah, that's not simplified, because there's a common factor of what in both the numerator and the denominator? Probably you would say 2. And how would you actually then go about simplifying? You would say, well, this is the same as 2 times 3 over 2 times 4, but 2 over 2, that's the same as 1. So when we simplify that fraction, we end up with 3/4. Okay? So what do? We identified the common factor in the numerator and the denominator and divided it out. That's what we're going to do here too. Okay? So a rational expression is considered simplified when there are no common factors in the numerator and the denominator. So then how do we go about simplifying? Well, if you're not in factored form, that's what you need to do first. First thing you want to do is factor the numerator and the denominator. Okay? So factor the numerator and the denominator. And then you're going to go through and divide out all common factors. Okay. So here's our process. Let's factor numerator and denominator and find all the common factors and divide them out. All right, so let's start with this first example. I have x cubed plus 3x squared divided by x plus 3. So let's look at the numerator and decide, how does that factor? Does it factor at all? Sometimes you'll have things that do factor and sometimes you won't have anything that factors. Now, if you remember the cardinal rule of factoring, the very first thing you want to do is look for GCF. Okay, and so if you're looking at just the numerator, do you see that we have a GCF? We have a GCF of x squared. So let's factor that out. This is x squared multiplied by x plus 3. Okay, x squared multiplied by x plus 3. Now the denominator, that doesn't factor at all. But do you see what's down there in the denominator? X plus 3? Looks common. So we can actually divide that out, and we would end up with just x squared, because that x plus 3 over x plus 3 is going to just equal 1. Okay, so we have simplified this rational expression to x squared. Now if I'm looking at the second example over here, x squared minus 1 divided by x squared plus 2x plus 1, I'm going to have to factor both. Okay, so remember that this thing is a difference of squares. I've got a perfect square and a perfect square, and that's going to factor into this, x plus 1 times x minus 1. And then the denominator here. This denominator, we've got x squared plus 2x plus 1, and we want to see, how does that factor? Notice that we want something that multiplies to make 1 and adds to make 2. I think that's just 1 and 1, right? So we would end up with x plus 1 times x plus 1. And we have both the numerator and the denominator now factored. Now what we want to do is take any common factors and divide them out. Okay, I don't want you to get in the habit of saying canceling, because what does that mean really? We just want to divide out anything that's in common, because it's really essentially 1. So we see an x plus 1 and an x plus 1 in the numerator and the denominator. And so now we can say that our simplified version of this expression is x minus 1 over x plus 1. Okay, and there we go. In our next video, we're going to start working with and actually operating with rational expressions. You're going to see a lot of common themes to when you were working with fractions in grade school. So I'll see you then.